Hey everyone, welcome back with a new lecture with how to calculate measurement uncertainty for microbiological measurements. And now, expression of measurement uncertainty in the test report. And this is very important subject. After you calculate measurement uncertainty, how to add this result of measurement uncertainty to the final result and provide or report this to the customer. So reporting. Measurement uncertainty, as mentioned in ISO IEC 17025 2017 edition, shall be reported in the same unit as the test result of the target analyte or target organism in microbiology. If the measurement uncertainty, and this is the first point mentioned in ISO 19036, if the measurement uncertainty based on intra-lab reproducibility standard deviation alone by calculation of technical uncertainty only, as I explained before, so this shall be made clear in the test report. You shall mention this in the test report. And this example from ISO 19036 also, you can write in the test report, after you will add the final result plus minus measurement uncertainty in the same unit as the final result, you can write the reported expanded measurement uncertainty has been estimated in accordance with ISO 19036 and is based on the standard uncertainty multiplied by a coverage factor K equal to, providing a level of confidence 95%, and that will be in every report you will provide to the customers. And if measurement uncertainty has been calculated based on calculation of measurement uncertainty or standard uncertainty for technical separately, for technical uncertainty and matrix uncertainty and distributional uncertainty, in this case you can mention in the final report the final result plus minus measurement uncertainty that you already calculated, and you can write this sentence in the final report: the reported expanded measurement uncertainty has been estimated in accordance with ISO 19036 and is based on standard uncertainty multiplied by coverage factor, providing a level of confidence of approximately 95%. But you will not mention anything else. Now, not only based on technical uncertainty, but based on calculation of measurement uncertainty from matrix and from distributional uncertainty and from technical uncertainty and also from sampling uncertainty. And it's recommended by ISO 19036 also that uncertainty should be rounded to two significant figures. You write 0.31 as example, not 0.2946, 0.31, 0.30. But very important point, rounding should be only for the final, for the expanded uncertainty, not for every calculation you will do, because that will affect on the final uncertainty. So rounding should be only for the final uncertainty, not for individual uncertainties. Individual uncertainties, keep them as it is. Don't make rounding to two significant figures. Example for how to express the final result in the final result or the measurement uncertainty in the final test report: 5 plus minus, you can write by this way: 5 plus minus 5, which is the result for the target organism, plus minus 0.31, which is the final expanded uncertainty, 0.31 log 10 CFU per gram, or you can write 5 log 10, log 10 values, 5 log 10 CFU per gram. This is for the sample result or target organism. And here you will add the limits from 4.69 up to 5.31. After addition of measurement uncertainty to the final result became this limit. So log 10 values and the limit. Log 10 values and the limit. 5 log 10, which is the result of the sample or the test sample, and here the limit after addition of measurement uncertainty from 4.69 up to 5.31, and here the measurement uncertainty also is 0.31, the expanded uncertainty. Or you can write natural values beside the limit also. 1 multiplied to 10 up to 5 CFU per gram, and this is the result of the sample, and this here is the limit for the natural by using the natural values. And after you will report the result to the customer, you will have decision for acceptance and rejecting of the samples, and this is the decision rule. Decision rule as per ISO IEC 17025 2017 edition now is mandatory and is very important. The analyst will not be able to decide if the sample will be accepted or rejected. The analyst only will provide the management by the result, and he already calculated measurement uncertainty in his validation or his verification. Then in the report, in the final report, there will be the result plus minus measurement uncertainty. Acceptance and rejecting of the sample will be from the decision, by decision rule from the management. They will decide based on many points that I will explain in details in a specific lectures. I will explain the whole standard for decision rule, which is ILAC G809 2019 edition, in a specific lecture, but here only I will give example for that. So decision rule will be based on specification limit. In a specific target organism, after you count the colonies as example, the specification limit, the acceptance or rejecting limit will be as example 30 log 10 CFU per gram. 30. So higher than 30, sample will be rejected. Lower than 30, the sample will be accepted. After addition of measurement uncertainty, the result came out to 29 plus minus 0.42 log 10 CFU per gram. So this sample will be accepted because after addition of measurement uncertainty, it will be 29.42. So this sample will be accepted. But if 30, the result came out 30 for this target organism, came out 30 plus minus 0.42 measurement uncertainty, 0.42 log 10 CFU per gram. So the result can be 30.42 or 29 point something. In this case, the sample will be rejected. In this case, the sample will be accepted. And decision now for the management. They will decide if this sample will be accepted or rejected. And in this case, they will base their decision on risk can be caused by this target organ, by this organism. Maybe is high risk from this organism, so in this case they shall reject. And also political issues, as example, if it's imported country, they want to receive a lot of samples, they have a problem in the market and they need from these samples to receive more samples from this. In this case, they will accept a lot of samples by this way. And also based on many other reasons. All of these reasons will be explained in the lecture for decision rule based on ILAC G809 2019 edition. That was the end of our lecture for today. In the next lecture, I will explain in details how to calculate measurement uncertainty using Excel sheet, and I will also show you that on the Excel sheet. Excel sheet will be provided, but after you will contact me. You can contact me, it will not be in the resources. You can contact me and I will give you the Excel sheet with a reasonable price. Thank you and see you in the next lecture.